Let's multiply two matrices. In this case, A is a matrix of size 2 by 2, and B is also size 2 by 2. Okay, so typically, before we even multiply matrices, what we want to do is check the sizes. So remember, A times B, there's usually an invisible dot, and A is size 2 by 2. And B is size 2 by 2. And so the first thing you want to do is check the number of rows. The first thing you want to do is actually check the number of columns that A has and make sure it matches with the number of rows that B have. So if these match, okay, this is the first thing you want to do, is check that these match. The 2 matches with 2. Okay, what does that mean? This implies that multiplication is actually possible. And so when we mean possible, it is actually defined. Now, the second part is very interesting. The second part here, if you check the outside numbers here, this tells you the size of A times B. So the size now is 2 by 2 as well. So AB has size 2 by 2. So this is the first procedure. Whenever you multiply matrices, you always want to check to see if it's even defined. In this case, A times B is defined. So why don't we write what this means? 0, the matrix here is 0, 1, and then 6, negative 7. Now let's put B right next to it. Remember, there's an invisible dot here. The invisible dot means multiplication. So if we put matrix B right next to it, we are now ready to multiply. So when we multiply matrices, it's going to be defined this way. What you want to do is take the first row in column the first row in matrix A, and coincide with the first column in matrix B. And so what you're going to do is do a pattern called multiply and add, multiply and add. So what am I really trying to say? We're going to take the 0 here and multiply it by 9. And then we add a 1 and multiply that by negative 3. And that is actually the entry of the first row and first column of A times B. I'm going to do a similar pattern with, let's say, the first row and second column position of A times B. So how do we do this? We first look at the numbers in the first row of A. So we have 0 and times a 0. And then we add those products, add the two products. What's the other product? The other product is going to be 1 times negative 8. And we continue with this pattern. So for the second row and first column position of A times B, we're going to need the second row in matrix A and the first column in matrix B. So we're going to take 6 times a 9 plus negative 7 times a negative 3. And that is actually, once again, the position of the second row and first column of A times B. There's only one position left, and that is the second row and second column of A times B. In order to get that, we need the second row of matrix A and the second column of matrix B. You may have noticed there's a pattern here. It might take you a while, but I recommend that you read all this stuff out loud and try to say it with all the patterns as well as you're multiplying. So what we're going to need now is a 6 and multiply that by a 0 plus a negative 7, multiply that by a negative 8. And there you go. You have all four positions. You have the 1, 1 position, the 1, 2 position, the 2, 1 position, and the 2, 2 position. Let's simplify that. The 1, 1 position, you simply have negative 3. The 1, 2 position, you simply have negative 8. And then 6 times 9, add 21. So 54, add 21. That is 75. So that's the 2, 1 position. The 2, 1 position is 75. And the last position here is 0 plus 56. And so that is the 2, 2 position. The 2, 2 position is 56. Okay. Therefore, what do we have? A times B is equal to another 2 by 2 matrix. Negative 3, negative 8 across the first row, and 75 and 56 across the second row. Well, if you are curious, you might be wondering what B times A is. Remember, let's check the size of B. It's 2 by 2. The size of A is also 2 by 2. So, not a total surprise here. If you did this off to the side, B times A, once again, 2 by 2, 2 by 2. The first thing you got to do is make sure these match, and they do. And the second is this will tell you the output or the size of B times A. Now, if you do the similar pattern as before, we first list B. B is what? B is going to be 9, 0, negative 3, negative 8. And now we write A. A is going to be 0, 6 down the first column. And then the second column is going to be 1, negative 7. Now I'm going to do this really quick just to illustrate a certain circumstance. So let's do the 1, 1 position. That will be what? 9 times 0 plus 0 times 6. The 1, 1 position, you get 0. The 1, 2 position, you get 9 times 1, which is 9, add 0 times negative 7, which is 0, so you're only left with a 9. 2, 1 position, in a similar manner, you get negative 48. And then negative 3 plus 56, so now you have positive 53. Whoa. Now, what does that mean? Therefore, B times A is a 2 by 2 matrix of 0, 9 across the first row, and negative 48 and 53 across the second row. Let's make that negative a little bit nicer. No, more importantly, you're going to see that, therefore, A times B is not equal to B times A. Pretty cool, huh?